Hello friends. Today's topic is network topologies. The way devices connect and how signals travel depends on the topology. In this video, I'll explain bus, star, ring, mesh, point-to-point, tree, hybrid and chain topologies in a simple way. Watch till the end and boost your knowledge. Let's get started. What is network topology? Network topologies define the physical or logical arrangement of devices in a network and how they communicate with each other. They play a crucial role in determining data flow, performance, scalability, and fault tolerance. Common types include bus topology, where devices share a single communication line, star topology, where devices connect to a central hub, ring topology, where devices form a circular connection, and mesh topology, where devices are interconnected with multiple paths for redundancy. The choice of topology depends on factors like cost, network size, ease of installation, maintenance, and reliability needs. Now, in this video, let's learn about these 8 topologies. Let's start the video. 1. Point-to-point topology. Point-to-point topology is a network configuration where two devices are directly connected by a single dedicated link. This is the simplest and most fundamental type of network topology. Advantages. Simplicity. Point-to-point connections are easy to set up and understand, making them ideal for small networks or connecting devices in close proximity. High bandwidth. With a dedicated link, the entire bandwidth is available for communication between the two devices, ensuring fast data transfer. Low latency. Data travels directly between the two devices without passing through intermediate nodes, resulting in minimal delays. Disadvantages. Limited scalability. Point-to-point connections are not suitable for large networks with multiple devices, as each device would require a separate dedicated link. Single point of failure. If the link between the two devices fails, communication is disrupted, making it a vulnerable setup. Distance limitations. The distance between the two devices is limited by the physical medium used for the connection, such as cable length or signal strength. 2. Bus topology. Bus topology is a network configuration where all devices are connected to a single cable known as the bus or backbone. This cable serves as the main communication line, and all devices on the network share it to transmit data. Advantages. Easy to install and maintain, bus topology is relatively simple to set up, requiring minimal cabling and configuration. Adding or removing devices is also straightforward. Cost-effective, bus topology requires less cabling compared to other topologies, making it a budget-friendly option for small networks. Suitable for small networks, bus topology works well for small networks with a limited number of devices, such as in a home or small office. Disadvantages. Single point of failure. If the main cable, bus, fails, the entire network goes down, making it a vulnerable setup. Limited bandwidth. All devices share the same communication line, which can lead to congestion and slow performance as the number of devices increases. Difficult troubleshooting. Identifying the source of a problem can be challenging in a bus topology, as a fault in the cable can affect the entire network. 3. Star topology. In a star topology, all devices in a network are connected to a central hub or switch. This central device acts as a conduit for data transmission, ensuring that all communication between devices passes through it. Advantages. Easy to install and manage. Star topologies are relatively simple to set up and maintain. Adding, removing, or relocating devices is straightforward, as it only involves connecting or disconnecting them from the central hub. Fault isolation. If one device or cable fails, it does not affect the rest of the network. This makes troubleshooting easier and enhances the overall reliability of the network. Scalability. Star topologies can easily accommodate new devices. Expanding the network is as simple as connecting additional devices to the central hub. Disadvantages. Central point of failure. The central hub or switch is a single point of failure. If it malfunctions, the entire network goes down, disrupting communication between all devices. Cost. Star topologies require more cabling than some other topologies, as each device needs a dedicated connection to the central hub. This can lead to higher installation costs. Additionally, the cost of the central hub or switch can be significant, especially for larger networks. 4. Ring topology. Ring topology is a network configuration where devices are connected in a circular loop. Data travels in one direction along the ring, passing through each device until it reaches the destination. Advantages. Efficient data transfer. Data travels in a specific order, reducing the chance of collisions and ensuring smooth communication. Easy installation. Setting up a ring network is relatively straightforward, as devices are simply connected in a loop. Equal access. Each device has an equal opportunity to transmit data, preventing any one device from monopolizing the network. Disadvantages. Single point of failure. If one device or connection in the ring fails, the entire network can be disrupted. Difficult troubleshooting. Identifying and resolving issues in a ring network can be challenging due to the closed-loop structure. 5. Mesh topology. Mesh topology is a network configuration where devices are interconnected with multiple paths, creating a redundant and robust network. In a mesh network, each device is connected to some or all of the other devices, allowing for data to be transmitted through various routes. Advantages. High reliability. Mesh topology offers high reliability due to the multiple paths for data transmission. If one path fails, data can be rerouted through another available path, ensuring continuous communication. Fault tolerance. The network can tolerate failures of individual devices or connections without disrupting the overall network operation. This makes it ideal for critical applications where downtime is unacceptable. Disadvantages. High cost. Implementing a mesh topology can be expensive due to the need for numerous connections and cabling. The cost increases significantly as the number of devices in the network grows. Complex setup. Setting up and maintaining a mesh network can be complex due to the intricate interconnections. It requires careful planning and configuration to ensure proper functioning and efficient data routing. 6. Tree topology. In computer networking, a tree topology, also known as a hierarchical topology, combines characteristics of both star and bus topologies. It consists of a central hub or switch similar to a star topology, which is connected to multiple other hubs or switches, forming branches like a tree, similar to a bus topology. Advantages. Scalability. Tree topology allows for easy expansion of the network. You can add new branches or levels to the hierarchy without disrupting the existing network structure. Hierarchical structure. The hierarchical organization makes it easier to manage and maintain the network. You can divide the network into different segments or branches, making it simpler to identify and troubleshoot issues. Disadvantages. Single point of failure. If the central hub, the trunk, fails, the entire network or a significant portion of it can be affected. This makes it a potential single point of failure. Complexity. Tree topology can be more complex to set up and configure compared to simpler topologies like star or bus. It requires careful planning and management of the hierarchical structure. 7. Hybrid topology. Hybrid topology is a network architecture that combines two or more different network topologies, like star, bus, ring, mesh, into a single network. This is done to leverage the strengths of each individual topology while minimizing their weaknesses. Think of it like combining the best features of different cars to make one supercar. Here's how it works. Different parts of a network can use different topologies depending on their needs. These different sections are then connected together to form the overall hybrid network. This allows for flexibility and customization to meet the specific requirements of a network. Advantages. Flexibility. You can design a network that perfectly fits your needs by choosing the best topology for each part of the network. This makes it ideal for large and complex networks with diverse requirements. Reliability. If one part of the network fails, the other parts can continue to function. This is because hybrid topologies often incorporate redundancy and multiple paths for data to travel. Disadvantages. Complexity. Designing and implementing a hybrid topology can be complex, requiring careful planning and expertise. This can lead to higher setup costs and require specialized knowledge for maintenance. Cost. Hybrid topologies can be more expensive to set up and maintain due to the need for a variety of hardware and the complexity of the design. 8. Chain topology. Chain topology, also known as daisy chain topology, is a network configuration where devices are connected in a linear sequence, like links in a chain. Each device connects to the next, forming a single pathway for data transmission. Advantages. Simplicity. Chain topology is easy to set up and understand, making it suitable for small networks or connecting devices in close proximity. Cost-effectiveness. It requires minimal cabling compared to other topologies, reducing installation costs and cable clutter. Disadvantages. Single point of failure. If one device in the chain fails, the entire network beyond that point is disrupted, as data cannot pass through the broken link. Performance bottleneck. Data must travel through each device in the chain to reach its destination, which can create a performance bottleneck, especially in larger networks with heavy traffic. That brings us to the end of this video. I hope you now have a clear understanding of network topologies and how they work. If you found this video helpful, make sure to like, share, and subscribe for more informative content. Thank you for watching, and I'll see you in the next video.